Well, hello guys, here Mr. G with another video, this time for the grade 11, and this one is about stoichiometric mostly. I'm going to leave the question in the description below so you can answer the question before watching the video. The question say an organic compound has the following composition by mass. And they're giving you the elements, carbon, hydrogen, and oxygen, and the percentage of each of them. The molar mass of the compound is twice the empirical molar mass. Define the term empirical formula. And what is empirical formula? That is the simplest whole number ratio between the elements of a compound. If you say that, you'll get 2 marks. Determined by calculation the molecular mass of the compound. Now, to do this one, the first thing we need is the empirical formula. We need the empirical formula so we can get the molecular mass. So let's go here to the bottom of the question. There's enough space for this one. This one is question 5.1.2. Question 5.1.2. Let's do it here. Now for this one, I'm going to draw a table, a very simple table in which I'm going to write element in the first one. Second one, I'm going to write percentage, not needed. Then I'm going to write mass. Then I'm going to write number of moles, and I'm going to use mass divided by molar mass. Then I'm going to use the ratio. Okay, so this is what my table look like. The elements I have is carbon, hydrogen, and oxygen. All right, the percentage is 54.55. The percentage of hydrogen is 9.09, and then it's 36.36. Okay, so that is the percentage. So out of 100 grams, or in 100 grams, the mass will be exactly the same. So this one will be 54.55 grams. In this case, this one is 9.09 grams. This one is 36.36 grams. And there is the mass for each of them out of 100 grams. That is the first part of the table. Let's erase this one because I need a little bit more space here. And this one, let's do it a little bit top. Number of mole is equal to mass divided by molar mass. Alright, so I'm going to do that one for each of them. You go to the periodic table to get the molar mass of each of the elements. For carbon, the molar mass of carbon is 12. When you go to the periodic table, this is 12 grams per mole. For hydrogen is 1, molar mass is 1 grams per mole. And then for oxygen is 16. So this one is 16 grams per mole. That is the molar mass for each of them you needed when calculating the number of mole. So I'm just going to substitute because I already did write the formula there. So in this case is the mass, which is 54.55 divided by the molar mass, which is 12, and that will give me 4.55. 4.55. We go to the next one and doing the same. We're repeating. So it's 9.09 divided by the molar mass of hydrogen, which is 1, and that will give you 9.09. All right, all this one is mole. Let's write there quickly mole. And then the last one, guys, is 36.36 divided by 16. And that gives me 2.27. Alright, so we calculated the number of mole for each of them. So now is coming the ratio. Now, how do we get the ratio? We divide each of them by the smallest one. Alright, the smallest one is 2.27. So here we have 4.55. Let's fix this one. 4.55 divided by 2.27, and that is equal to 2. That will give me 2. The next one is 9.09 divided by 2.27, and that will give me 4. And then the last one is 2.27 divided by 2.27, and that will give me 1. Okay, so the empirical formula is going to be C2H4O1. That is the empirical formula. Empirical formula. Alright, now quite simple. The question said, or the question asked, determine by calculation the molecular formula of the compound, and they are telling you that the molar mass of the compound is twice the molar mass of the empirical formula. Guys, it's very simple. All we have to do is to double each of them. So the molecular formula, because they're telling you is twice, it's not always like that. Be careful. In this question, it's like that because it's double. So it is C4 H8O O2, and this one is the molecular formula. This is the molecular formula for this compound. End of the question. Okay, let's go to next one. That was a good question to start. A teacher demonstrated a group of learners the impact that limiting reagent have on the amount of product formed during a chemical reaction. The teacher uses the following chemical reaction. Zinc plus hydrochloric acid will give you zinc chloride plus hydrogen. The teacher uses the following setup to investigate. Know the following here. You are collecting the H2. So in this syringe, you are collecting H2, that is the product. So you are measuring the volume of H2 collected, okay? So there's two experiments, and you can see that they change the amount of zinc. In other words, zinc is the limiting reagent. This one is the limiting reagent, okay? That is important to know. Define limiting reagent. And then the substance, the limiting reagent will be the substance that completely used up first during a chemical reaction. There's 2 marks for that one. I think I didn't give the marking here, and then let's give marks quickly. There's 1 mark for calculating number of mole. For each of them, there's 1 mark for the ratio, for all the ratio, that is 4 marks, and there is 1 mark for the final answer. That is the marking there. I forgot to do that. Determine by calculation the limiting reagent in experiment 1. Well, they say determine by calculation, so we cannot assume that zinc is the limiting reagent, even though in the experiment they're using different amounts. Okay, so let's do the calculations to determine the limiting reagent. And this is very simple. This is question 5.2.2. Okay, so for limiting reagent, what we're going to do, step 1, calculate the number of mole of the reactant. Number of mole of reactant. That is the first thing we are going to do here. So number of mole of zinc is equal to mass divided by molar mass. And let's use experiment 1. So in experiment 1, the mass of zinc was 7 grams. And the molar mass of zinc, you go to the periodic table, is 65. So the number of mole of Zn, let me go here, of Zn is equal to 0.11 mole. We are going to do the same for chlorine or hydrogen chloride, the sulfuric acid, but we already know the number of mole of HCl is given to us, which is 1 mole, right? 1 mole. So now step 2. In step 2, you are going to use the ratio. All right, either one. So we're going to say Zn to HCl. The ratios, remember, are the numbers at the front. So the numbers that could be here in the equation are the ratios. So we have 1 for zinc, 2 for hydrogen chloride. Zinc, we calculate, we can use it. We say if we have 0.11 mole of this one, how much of hydrogen chloride will I need? And I'm going to do cross product here. All right, cross product. So we'll get, that means that I need equal to 0.22 mole of hydrogen chloride. So I need 0.22 mole of hydrogen chloride to use up the 0.11. However, I have 1 mole, so I have much more than the one I need. Therefore, the limiting reagent is the zinc. Zinc is the limiting reagent. I need less hydrogen chloride than the amount I have. In other words, like we said before, zinc is the limiting reagent. How do we give marks here? One for this formula and one for substituting 7 divided by 65. Another mark for the ratio, 2 marks for the ratio, there's 4 marks, and 1 to identify that zinc is the limiting reagent. Okay, so that is the way of doing it. It's quite simple, guys. If you do this one and this ratio with the mole, ratio is always with moles. Okay, that will give you the, let's fix mole, it's not like that. There we go. That will give you the, which one is the limiting reagent. We get that we need 0.22 of hydrogen chloride to use up 0.11 of zinc, but we have 1. So we have more than we need. And that one is how to determine the limiting reagent. Quite simple. Now question 5.2.3, how will the amount of zinc chloride produces in experiment 2 compared to that in experiment 1? Well, so we go here, say write down the higher than, lower than, or equal to, explain your answer. Now, they changing the number, the amount of zinc, which is the limiting reagent. So they're using now less zinc than before. Therefore, you will get less product, guys. If you're using less zinc, you will have less product because zinc is the limiting reagent. Now, if you use less hydrochloric acid, does not necessarily mean you will get less product, because you have 1 mole, which is a lot. So let's say, for instance, if instead of 1 mole you use 0.9 mole, you will still get the same product, because 0.9 still less, still more than the amount you actually need. You only need 0.22. All right, but they decreases the amount of zinc, which is the limiting reagent. So the answer here is going to be lower than. That is the answer here, and then you will get 1 mark for that one. Say, explain your answer. Zinc is the limiting reagent. So you have to say that zinc is the limiting reagent. You will get 1 mark for saying that one, and then you use smaller amount in experiment 2. It's the limiting reagent, and even though you're still using less than experiment 1, so obvious you will get less product. Be careful, not the same if the change number is the hydrochloric acid. If the hydrochloric acid is different, you have to make sure you look once more to the amount that you actually need, so it could be the same. Question 5.2.4, experiment 2 was carried out at 40 degrees Celsius. The molar volume of hydrogen gas at that temperature is 25.7. Be careful here, because in this question they're telling you that the molar volume at that temperature is going to be 25.7 decimeter cubic per mole. Mole is not with a D. Per mole. There we go. Calculate the volume of hydrogen gas produced once the reaction reaches completion. Very good question. So let's come, I think it's more than enough space here. And this one is question 5.2.4. They say experiment 2. So the first thing we have to do is to calculate the number of mole of the limiting reagent in experiment 2, which is the zinc. So here we go, and we say number of mole is equal to mass divided by molar mass. What we have is the mass in the question, and the mass is 3.27 divided by the molar mass of zinc, which is 65. I'll show you how to do it in the periodic table, and we get that this one is 0.05 moles. Okay, so this is the limiting reagent. Second, we are going to get the ratio between what they asking and what we know. We know for a zinc, so it's going to be the ratio between zinc, and in the question they ask us for hydrogen gas. So the ratio for hydrogen gas, we coming back to the question, is H2 is 1:1. So this is for hydrogen 2, the ratio is 1:1. It means that if you have this number of mole of zinc, you will also get 0.05 mole. You will also get the number of mole here to be 0.05 mole. So we know the number of mole for hydrogen gas. Now we know we go to the formula of number of mole equal to volume divided by molar volume, and we substitute. But be careful, because the molar volume is given to us and is not 22,4. It's the number they gave us here, which is 25,7. There we go. And the volume is going to be 1,285 cubic decimeters. Guys, this is the end of this question. It's a very good question. It's a very, very good question to practice. One for the formula, one for the substitution, one for the ratio, one for this substitution here, and one for the final answer. And we are done with the video. We're done with the question. I hope it helped. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.